I'm audible to you.
Yes, sir.
Yes.
Yes, sir.
Some more are joining, so I'll start the session in 3 to 5 minutes. So let all the join together. Then we'll start, right? Thank you for your joining. So I'm audible, right? Hello, guys. Good evening. Hello.
Yes, sir. Yes, sir. You are audible.
Yes, all right. Okay. Thank you. Thank you for your response. And this is a nice evening, and it's cold these days. And I hope you are all in good shape and fresh mind to join here. Actually, I find this time suitable for me, so it is hard for you, I think, in joining in evening time. And okay, welcome to this doubt clearing session, and also the interactive one that I believe to be. So first of all, I want to know that how many are comfortable with Hindi and how many are English. So
Okay. Good evening, everyone.
yes, yes,
Uh, I think I will
yes.
be. I
Yeah,
think I will be comfortable with English since I'm from Africa in
okay,
Lesotho.
okay, okay, fine, fine. Oh, so which country you are from?
I'm from Lesotho.
Okay, okay, fine. I'll be there. Actually, some of you, I think, maybe may have some problem in English. So I'll be in both way. Uh, I'll be doing the classes and the lectures. So let me introduce myself. Myself is Devjyoti, and I'm selected for PMRA under Cycle 11, and actually my the job is here to show some questions and discussing the questions with you, and there should be some interaction between you and I. So I hope that whatever possible from my side, I'll give it to you as many as possible, and I also expect the same from you, that I will get some knowledge from you. So I also expect some learning from you. So let it be interactive. So whenever you have some doubts, just keep on asking me. I'll be always with you. So make it a interactive session, not with the exam mindset orientation. So actually, the thing is that 2 hours is a much long duration. So actually, it is about 45 to 50 minutes maximum. So I am thinking about, I have planned something regarding managing this time. So first of all, I will summarize the three lectures that already you know that Professor Bhattacharjee already shared these lectures. So I'll summarize the lectures, and I'll mention some critical points. If there is a discussion, I'll discuss, and I'll just summarize these three lectures, and then I will start the problem of the assignments quickly, week 1 assignments. So um, so this is the way that I want to arrange, and also at the end, I also wish to discuss some questions that I have also prepared on my own, and I will solve it together. And also at the end, there is also a lot of questions that may be helpful for your preparation in competitive exams. So that also I'll cover in this session. Let me say that this session will only occur Saturday from 6 to 8. So no need to join before that and after that. So be careful with the timing, and try to be cautious, and to join within 10 minutes from the start of the session. So, so any suggestion, that is my plan. If you have another plan, you can share with me directly. So, is there any plan from you guys? How can I manage? So this is my planning. So if okay, from will we be able to watch the recorded video online if missed? Yes, yes. I'll also upload this link, and also to the NPTL, and also prepare that channel. So I'll also let you know the channel name and also link. So it is always available in NPTEL site. So they have the log sheet. So I'll be uploading the lectures and all the documents in Google Drive form to the NPTEL log sheet. So it will be available online. You can easily access to that. So this is my planning to manage the whole timing, 6 to 8. So I think is there any suggestion? Please share with me. I can go with it. So is there any suggestion from you guys? So this is my planning. So it is not as strict that if you have any other plan, to just share with me, and I'll I'll do that way, as I'll do try to be and do it with my best efforts. So whether we can get the lectures in PDF form? Yes, yes. PDF form means um, actually the PDF what I will prepare, that will be in Google Drive form. So that PDF is like some slides, some slides. So that slides will be accessible from your end. So that is it. Okay. So shall I start? So I think yes. So first of all, uh, uh, I will quickly summarize the lectures. Okay. Uh, I think it is not. I'm sharing my screen, right? Share my screen. I think my screen is shared. Um, so I think my screen is also visible to you. so, so I am starting. So now this is the week 1 lecture. Actually, I want to show you these slides I have prepared for you. This assignment questions and related informations. Okay. So I'll come later. Sorry, I'll come later uh, after finishing the summarizations. Okay. So this is the thing, and then so first of lectures. So this is the you have already access to it. So this is the concrete, and the concrete is made up with cement, sand, mortar, and aggregate. So the cement, that is also the one portion is also occupied with cement paste. Cement paste is the cement and water. There's no sand. So aggregate is the like skeleton. It's a 60 to 75% volume. So paste is 25 to 40%, right? So so this is the and 1 to 2% of voids. So now this is the cement and sand aggregate the samples are showing. So and this is the moreover, if you go at advanced, and then there is a concrete, and also it is with accelerator and segregator, we can increase and decrease the setting time of the cement and ply. So with the mineral admixture, fly as silica, fume, rice husk also there, and chemical admixture used for like property and maintenance. There are some admixture, and there are some their functional functions are also mentioned. So specific performance enhancement, chemical admixture, and mineral admixture is for improvement of long-term strength and durability. So using admixture and high strength performance concrete can be designed. So with the admixture, say the admixture part is come in the design mix. So in the conventional mix, there is no admixture, and like there is a three component: the cement, cement, coarse aggregate, fine aggregate. So three components. So like a standard mix. the design mix, we can use these quantities admixture. So, so advantage and disadvantage, yes, low life cycle cost. Actually, the um, so life cycle cost is the actually maintenance all the cycle means so it includes the initial production cost, maintenance cost. So it is the total cost actually. So, so this way it can summarize it. So moldability is the moldability. You can mold the if you made some cement paste, you can mold according to your own shape. So it's a plastic behavior. Robustness, when it is um, it comes under compression, it is robust, but in the tension, it is not robust. So that way it can characterized. Can be designed with desired property, low tensile strength that also verify, and low ductility. Ductility means if you increase the that if you put some tension or energy, it will absorb the energy and it will break. So ductility means how long it absorbs the energy. So ductility, the actually if you go to the if you see the stress and behavior of steel section, so after reaching some end point, it stretches. So that stretch, the straight line portion, horizontal portion is much long. So and then after before it fails to particular failure points. So from yield to failure, there is a long duration. If it is a long, then that it is more ductile, so it absorbs more energy. But on metal material, it does not show that ductility. So it's just break at 40 just a 90-degree angle. But for the ductile material, cup and cone failure uh, will take place. Cup and cone failure, I'll show you sometimes later. So this is the concrete composite. This is a various type of concrete: normal strength, high strength concrete, ultra performance concrete, and also this is the polymer concrete, polymer cement concrete. So this is the concrete composite and reinforcement. So this is the lime and silica, and actually first of all the lime was used, lime and um, a construction material. And then with the lime and volcanic ash in the Roman times, also they use this building material. And in not in India, it is lime and shuki. So actually, this thing is the lime. Yes, actually, I prepared some. Yes, actually, the lime plus silica, if you mix it up and reacts, it makes some compounds and it reacts with water, and then it must get hardened. And when the lime reacts with silica, then it makes the amorphous silica. So amorphous silica is like a less stable and ionized. So it reacts with water more rigorously. So and when there is a crystalline stage, when there is a crystalline stage, so in crystalline stage is not reactable, so it is an organized way, so it's stable form. So when there is a lime and silica reacts, there is amorphous silica formed. So in same way, it's a lime surki, then also it reacts this way. The surki is nothing but a clay. See, surki and silica are actually that is a clay component. Actually, the clay component consists of silica, alumina, iron. So um, it's like a clay. And volcanic also ash also, it is composed of particles. So this is the way it forms. So most of actually the now this history comes the Portland cement, actually in the England is a Portland called Portland places where this such type of cements also get first found. So this is the thing. So I think this also are relevant points. So this is the wet process. So wet process, actually this is the obsolete process. Actually when there is a slurry and there is some slurry in cement paste, we do it in wet process. We follow the wet process. However, if there is a actually nowadays it maintains the dry one. So this is the wet and dry process. So modern process is dry, and grinding depends on raw material fineness, typically 10 to 30%. So fineness should be such a way that in my 19 microns, see the 100 gram. If you take the 100 gram of sample, if you pass it through 90 microns after grinding, so it should retain 30%, and 30 grams should retain on the 90 micron chip. So homogeneous meal is introduced in the top. Actually, this is the process. So this is the process is showing the cement production, how it is get into this preheater, then it passes through stages of temperature. Then after that, it will tumbling action will be there, and also it forms some solid, and then it makes some clinker, and with some clinker the gypsum is added. Finally, the cement is done. So I'll come to this later. So this is the now the raw material suspend is also the thing, the same thing also introduced said here. So decarbonation process and the various stages of temperature that I have also explained, that includes this 1500 degrees Celsius, where the and actually the thing is all the temperatures, during the temperatures various cement compounds are formed. Cement compounds are C3A, C3S, C2S, C4F. C3A means calcium aluminate, tricalcium aluminate, and dicalcium silicate, tricalcium aluminate, tetracalcium aluminum ferrite. So actually the C3S and C2S have both some name. So both have some name. So C3S is the halide and C2S is belite. So you can remember it this way. So it is a short terminology, and also in some way will abbreviated this composition. So this is the how it goes with the cement production, limestone, then grinding. So I'll be better showing with this. This is we just make some ingredients. So ingredients means calcium carbonate. Calcium carbonate is like the limestone, silica, and clay shells. We put together, and also we burn it. So this free water is getting evaporated, the dehydration evaporated at a 50 to 60, 600, between 50 to 600 degrees Celsius, free water get evaporated. Then just 590 or 550 at the stages, clay decomposes, and the calcination zone, lime decomposes. Then after lime decomposes, that's about 909. You can see it is about 900 degrees Celsius lime decomposes, and also initial formation of setting C2S, that dicalcium silicate out, is also belite. It's 100 something, between 1000 and 1350 degrees Celsius, and also in clinkering zone, and around 1500 degrees Celsius, the CTS formation is done. And after that CTS formation, there is a tumbling action. The tumbling action, it get solidified. That mold gets solidified, and it forms clinker. So clinker will get grind with the gypsum. So gypsum is like a chemically compound, CSO4 H2O. So if you add the gypsum, it prevent the flash sheet. The flash sheet I'll come to later. So it is a false sheet also there, flash sheet also there. If it's more calcium sulfate, then this false sheet also there. So the gypsum is like a maintaining some setting time. If it is the setting time is much faster, then after, if there is some delay, then cement get clogged. So there should not be like, there should be some setting time duration. So that part is maintained by gypsum, adding the gypsum. So this calcium carbonate is already mentioned here, that silica, iron, that all are mixed up and heated with 1500 degrees Celsius temperature. Yes, yes, yes. So the thing is, after grinding, after final formation of the cement, and after grinding, it get cooled, and then the gypsum added. So these are the stages. So after cooling, the gypsum added, not before cooling. So you have to take care of this. So this is the also the clinker I have also mentioned. This is the ordinary Portland cement. This all this process is based on the ordinary Portland cement. Actually, in the England, this process has been followed, and they produce this cement. So it is like a methodology that they developed. So it's a, and also you can see the India's second largest after China. And then these are the composition of the Portland cements, where the CaO, actually CaO will come to this abbreviation. CaO means calcium oxide. We can just write SiO2. We can, for the sake of for the sake of mm, uh, for the sake of uh, my our codes, will directly write SiO2 with S and Al2O3 to A. So this is the thing. Uh, so this is the composition. This is the composition. All the this is CaO formed 60 to 67%, and SiO2 17 to 25%, Al2O3 3 to 8%, 0.5 to 6%. So um, these are the components. So all the abbreviations are there. So this is the abbreviation. Also, you can check. And also, this is the lime saturation factor. The lime saturation factor is that carbon divided by 2.8 sulfur plus silica, sorry, 2.8 silica plus 1.2 alumina plus 0.65 iron, 100%. So this is the ratio or the parameter how can characterize the cement compound. So it is a LSF, means the lime saturation factor is more than 100%. So in free lime, so results in free lime. So it is 100% is free lime is there. So free lime is it can react more with the composition. So higher the SR means means more C3S. SR means silica ratio, means C3S is more, and less C3A means and less C3A and higher AR means alumina ratio means higher C3. So this is the Box compound. This the also the with the Box equation you can find this relation where you can compute the C3A, C2A, C4F, C3A, and C4F, and with the calculation. And here is the bar. This S bar is nothing but SO3. So these are the process where I already mentioned. So these are the stages how it works. Um, the calcination, that is lime is put and low, and with the lime the clay minerals are there, and after 600 degrees, after before the 600 it reaches the 600 degrees Celsius, and the water get evaporated. Then at 800 degrees Celsius the CO2 get evaporated. Then 1000 is belite is formed since C2S, and also the free lime makes some portion in the between 1000 to the between 1000 to 1200 degrees Celsius, and after at the 1500 degrees Celsius elite is formed. So Um, the heat of hydration, actually, the heat of hydration, see, this is the heat of hydration. You can check uh, the C3S, C2S, C3A, and C4F. For all the, actually maximum is C3A. C3 is the quickly react with water, because yeah, I can show you later on how it reacts. And the actually it gives the C3S give the that ultimate strength and long-term strength, actually. And actually say initial strength, C3s give the initial strength of the cement, and C2 is the ultimate strength. C3A is not that giving strength, but it heat of hydration is much more. So actually in the aluminate, the silica alumina actions govern uh, this C3A reactivity. So, and after that, it comes that these are the stages where the components are mixed, and then oxides are formed, then cement compounds are there. Then after that, with the formation of the cement compound, the gel formation is there, formation of the COH. So these are the summary. And so with this, it completes the stage, first process of model lecture 1. So I'm closing it. And now lecture 2. Yes, lecture 2, I'll just summarize this. So it's lecture 2 is like a, mainly hydration process and bonding actions, all that there. So these are the things you have to take care of. Uh, so Yes, so already these are the, so this is the molecular intermolecular structures. So intermolecular structure means the how it is bonded with the other atoms. See this is silica, the tetrahedral structures. The silica is the center is atom, and in this tetrahedral shape, the oxygen is arranged. The four oxygen atom is arranged with the one silica atom. So this way it, and so it is the repetitive structure, and with the repetition, it makes silicates. So this is the silicates. So this is like a quartz in 3D network, tetrahedra is formed like with each oxygen bonded with the two silica. So in crystalline quartz, the tetrahedra are arranged in three-dimensional periodic pattern. So in crystalline silica, so tetrahedra are randomly bonded. So in a three-dimensional three-dimensional network, other oxide, silica and other oxide can be dissolved to yield the number of both crystalline and non-crystalline silicates. So these are the structures. So in the structure, what you see this allied structure. So allied structure is like a triangular shape. So you can see. So you can see um, I don't know why it is showing the remaining meeting is 2 minutes 53 seconds. I don't know. I think after 2 minutes, I think I have to again join the meeting. So please don't leave. So I think there is something is there. I haven't checked. So after two minutes, I think it will end. So I'll again join. Please join that time also. So don't leave the session. Uh, so this is the subshell of A and B. So this is the calcium ion, and also this is the orthosilicate ion. So the large portion of orthosilicate, and between the calcium ion is there, and inside the oxide ion. So if it is arranged together in the structured way, so this is from the alide. Alide means C3S, and after in the balide, in the balite formation, it is different. So in between the oxalicates and calcium ion are arranged around it. So, and also the C3 formation. So you can check the aluminum tetrahedra form 6AiO4. is arranged. So where this aluminium, so aluminium is red one. See, 1, 2, 3, 4, 5, 6. So 6 aluminium are there, uh, uh, and the oxygens are 18. So these are the oxygens, and they are the negative ion charges. So these are the aluminum structure that you can also aware with this, and this is a polymeric. It is a polymorphic and differs structurally by minor deformation, uh, and from basic hexagonal. Actually, polymorphic means it can stretchable polymer. It's a polymeric reaction. So that is the thing. So also it is aluminum ferrite. As a ferrite structure is as Ca2 and LaPO4, tetrahedra and octahedra. So these are the formation where the FeLO6 are been between. This is the triangle rectangular shape, and calcium and between are there. So this is the aluminum LeFO4 that is in between. So common features. So common feature is a large anion, a small size cation. So actually here one point is come because of this anion is a difference in size of anion and cations. Um, there is a space made. This because of this